Hey Geometry, today we're going to go ahead and dive in to the basics, the building blocks of what we're going to be working with the rest of the year. This stuff should seem kind of familiar. You've dealt with it before. So we're looking at the concept of points, lines, and planes. Pretty much everything else we work with can be made out of these things. These terms are this one thing. These are kind of the basic things that we don't prove these. A lot of the stuff throughout this year we can kind of prove why it is the way it is. Here we can kind of just describe and draw these elements, but they're kind of so basic that we don't have. There's no like smaller thing to work with. They're kind of like the quarks, if you know what I'm talking about with physics of geometry. These little bits. But you've dealt with points. You've plot points on a graph. We call it a coordinate plane. So you've got maybe that term, it's this flat surface that you work on. You've been working mostly in 2 dimensions, and you've graphed lines on that. So you should have some of those. We're pretty similar to that. We maybe add that third dimension in a little bit, but otherwise we're pretty much dealing with those exact same ideas. So a point indicates, kind of the best way we can describe it, a location. All right, so it indicates a location, and it has no size. So it's just like my kids would call it like a dot. It's nothing. And when we draw it, if I draw this dot, that dot is way too big. All right, a point theoretically has absolutely no size, no width, no length, no area, no volume, no nothing. Right, it's just a location. In your graphs before, it just represents an x-y coordinate. Maybe now, once we're in, if we get into 3-dimensional space, so we had x and y, those were our 2 dimensions. If we add a third dimension, height, we call that z. So x, y, and z. If you had those 3 locations, those 3 values, you get a specific location. A point happens there. To name points, we use capital letters. So, for example, we might call something point A, and so we would maybe label it on a graph. We use capital letters. We tend to stick to certain conventions. Capital letters for this, lowercase letters for lines, uppercase again for planes, but a lot of times they're kind of italicized. We do these things just to kind of make it easier to kind of know what people are talking about if we're kind of all working in the same format. It wouldn't be impossible to name a point something other. You could give it a name. You could say, oh, this point, that's Bob, and this other point over here is Jimmy. But it's going to be kind of weird, and people aren't necessarily going to know what you're talking about. If you just kind of label a point with a capital letter, they'll know, yep, that's the label for the point. I know what's going on here. I understand it. And so if we all kind of stick to those conventions, it helps us agree. But we might have that point, and so you could have other points around, but yeah, there's an example. A line, our next building block that we'll work from. So a line does actually kind of add in 1 dimension, right? We have you've graphed on like a number line. We have now 1 dimension. We can have length on a line, but it still has no thickness, no area to it. So it's like as I draw a line, if I draw a line here, that's already way too thick. So it's we kind of, it's really an abstract picture of what it really is. It's this perfectly thin little strand, thinner than a spider web's a single strand of a spider web. But that's the concept. The way that we name lines. So I guess a line contains infinitely many points. So infinitely many points. So if we take all of the points in a straight direction and we line them all up, a line contains infinitely many points. Even actually just a segment of that line, we'll get to segment in a little bit, but even just a chunk of that line, there's actually infinitely many points along that line. And you kind of got that idea with the number line before. The way we name lines, we tend to do a couple of ways. We can name a line with any 2 points. So you pick any 2 points on the line, and that's enough to define it. And we'll come back to that a little bit later. So pick any 2 points on the line, and so say on this line I've got points A and point B. So I could call that line AB. So I mean, you can do it other ways, but we'll tend to do this. We'll use the standard notation. But you could say the line from through A and B, but we use this little notation where we put AB, and then we put the little kind of line symbol over top of it, a line with arrows at the end, and that kind of shows it does go on forever in each in two directions, right? So this. I draw the line, I put the little arrow there, but really that line goes on forever in the other direction. And I'm drawing this on a two-dimensional surface. In 3 dimensions you can have lines coming at all kinds of different angles, and again, they just go on forever in those directions. So that's kind of what that little symbol shows. But we could just have easily have labeled this BA. There's no, we maybe default a little bit to the alphabetical order, but that's an extremely weak convention. Calling that line BA would be perfectly fine. The other thing we'll do sometimes is we'll use lowercase letters. We tend to actually go the cursive or italicized with these. So I might call this line L, and they'll use like a cursive letter for that. So line L, or whatever letter you want to use. But sometimes we'll label a line rather than the point. But we can define the line in terms of the points. And then our next piece, we add that second dimension. So originally we had no dimension with our points. Then our line adds 1 dimension. We start to have length, and then our other dimension, we get a plane. So a plane is hard to draw because paper is almost a plane, right? It's bendy and it's no thickness, right? This actually does have thickness, so it's not quite a plane, but it's kind of hard to draw a plane on a plane. But what we kind of do to try and imagine this 3-dimensional space is we kind of draw a little bit of a perspective thing. We draw something like this, and I'm not always great at this, but we draw like a parallelogram because it's just a piece of a plane. Really, this plane stretches on forever. It's flat in all directions, but we kind of draw it from perspective. It looks like a piece of paper, maybe just kind of sitting out there in 3-dimensional space. But we'll draw the plane that way. The way that we name a plane is, so no longer can we just use 2 points. So this line, I could use those 2 points. There's no other lines that could be confused with, right? There's one line that goes through those 2 points. A plane, we actually need a third. So if we choose points A, B, and point C, now if I have 3 points on that plane, on that flat surface, now it's fixed. If you just have 2, if I just have like 2 points, I could have a line through that. There's actually a bunch of planes that could go through those 2 points. So we actually need a third plane, and kind of getting ahead on a term here, we actually need a third non-collinear point. If you have all 3 of those points are in a line, it's actually not good enough because there's, in a line you could have planes coming through at, all bunch of different angles. So you need 3 points out there that are not in a straight line. It's kind of that collinear piece. But if I have those 3 points, so we need so any 3 points on the plane. So we have any 3 points on the plane, and we just use the word, we could call this plane A, B, C. That's one way we can do it. The other way we will label planes sometimes is with a capital letter, and we might call this plane K, and a lot of times in your book those will appear italicized, but we could also just call that plane K. K. I got an eraser on here. I need to scratch that out. Plane K. All right, so those are the basic building blocks, and we'll continue from there.